to a capable OpenBSD computer, as well as an OpenBSD window maker desktop setup, and we show a little bit about real-time data compression, as well as the love for pipes in this week's episode of BSD Now. BSD Now, episode 286, Old Machine Revival, recorded on the 20th of February 2019. Hello, I'm your host, Benedikt Reuschling.
And I'm Alan Jude.
And we have a new episode for you, and for the people who haven't seen it yet, we also have a freshly facelifted website. That's cool and exciting. So, Alan, I think you can tell us a little bit more about that.
I don't know, it's just the podcast network is switching to this other system, and it builds the website a little easier and handles the show notes and so on. It's less work for us, and it should mean that the show notes appear on the BSD Now site as soon as they're available, rather than they were often quite delayed.
Okay, so yes, we have a little bit of freshness in that department, and we also have, as every week, headlines for this little episode of us. Adding glue to a desktop environment is the first one.
Yeah. So I say in this article, we'll put some light on a lot of the tools used in the world of the Unix desktop environment, specifically for customization. Talking about things like WMCTRL, which is Window Manager Control, Window Manager Utilities, X Environment, X Truss, Window Info, lots of other gobbledygook of names here.
Utilities, yeah.
Including one called Trigger Happy. If those names don't make sense, then this article is here to help. So you know, a lot of the questions regarding these tools and what they're usually for don't actually grasp the purpose of a window manager or what a desktop environment actually is. So they want to talk a little bit about that. First, X and other bits about X Windows in general. Then taking the X framework and adding a window manager and a desktop environment, which are actually not quite the same thing. Trends and evolutions of the window interfaces, as you know, it's been quite a few years since the first versions of X came out, and the way we interact with computers is a little different now. Then it talks about making everything faster or plainer, and then looking at actually writing a window manager and how an X window manager works. But even without reading all the previous content, this article will explain how to customize things a little better. Mm-hmm. So this one looks a little bit at how to debug things, how window manipulation actually works, how to simulate interactions, how to extend those manipulations, and then how to set up hotkeys and layout managers.
Oh, very nice.
So when you have an X server, it'll have multiple windows, and then you can also have a toolset and a window manager that will interact with those windows. And it talks a bit about how, window manipulation is, windows are just objects that are living in the X server and have some visual representation when they're mapped to a screen, which is when stuff shows up on your screen. Windows, like any other objects, have attributes and properties attached to them. Another interesting object within the X server is the pointer or the cursor, where you actually interact with the windows. The tools in this section manipulate those bare objects using the X11 protocol to speak to the X server. They do things such as list the identifiers of the window objects within the X window server, so you can get a list of all the windows that exist and their basic properties, or that you do things to them such as moving them, resizing them, changing the order that they're stacked in, or labeling them, hiding and unhiding them, and so on. So two popular tools for these functionalities are WM Utils, which is obviously your window manager utilities. And there's another one that's just called the window utility, which comes from the X11 extras package on Debian. And it allows you to do things along with other utilities used for Windows listing, such as WinSelect. You can kind of get an idea of what's happening in the interface. Then you can also simulate interactions using tools like WinMacro to actually make up a macro. So when you want to do certain operations, you don't have to do each step manually. You can basically script that.
That could be useful.
You can do extended manipulation. There's a standard called ICCCM, the Interclient Communication Conventions Manual, which was devised in 1988. And another one called the Enhanced Window Manager Hints. That was not long after, built on top of it, and allows you to do things to different windows. And it talks about the hotkey daemon and how to use something like Xbind keys to make your own keybinds. And also a layout manager like GTOW for GNOME or Grid Manager for other window managers and so on. And then if you're familiar with Truss on FreeBSD, which can let you see the syscalls that an application is making, there's Xtruss to actually see the X calls that an application is making, which help you understand what it's doing.
And I guess most people are familiar with Xkill.
I've never used that, but yeah.
Really? You never had a stuck window to just kill it with the little bomb icon?
No. That'd be interesting, though. Anyway. If you're interested in understanding how X works, or even digging deeper into the series into how you actually write your own window manager, well, check it out. It's got lots of good stuff in there if you want to actually get into customizing what your computer looks, what your interface looks like, or even building your own window manager.
And also the interaction between these different components in the X server.
Yep.
Very nice. But that's not all that we have for you today. We have also the headline Flashing the BIOS on the PC Engine's APU 4C4 by Sean Webb here on GitHub. He posted that because apparently he loves the PC Engine's APU devices, so he wrote a little bit about it. He writes, I use them for testing hardened BSD experimental features in more constrained 64-bit environments and firewalls. Their USB and mSATA ports have a few quirks, and I bumped up again a major quirk that required flashing a different BIOS as a workaround. So this article details the hacky way in which he went about doing that. And the reason for this hacky way is because the upgrade of OpenSense from 18.7.10 to 19.1 failed partway through, leaving him in an unbootable system state. What prompted this article is that something in either the CAM or the Guillaume layer in FreeBSD 11.2 so caused the mSATA to hang, preventing the files to be written. And apparently OpenSense 18.7 uses FreeBSD 11.1, whereas the recently released OpenSense 19.1 uses hardened BSD 11.2. So don't get confused here with the version numbers. He reached out to PC Engines directly, and they let him know that the issue is a known BIOS issue, and flashing the legacy BIOS series would provide him with a working system again. And so it happens that a new legacy BIOS version was just released, which turns on ECC mode for the random access memory, and he gets a working OpenSense install and ECC memory. Good combination, I would say. And so, although he's using an APU 4, these instructions should also work for the other APU devices. The BIOS ROM download URLs should be changed to reflect the device you're targeting, along with the BIOS version you wish to deploy. And of course, special note, there be dragons, be careful, make backups. All these things could crash and burn anytime. So he's primarily writing this article to document the procedure for his own purposes. And yeah, there could be errors in there, so be careful what you type into your terminal. So let's get on with it. First, you need a few things before to get started. First, some kind of hardened BSD installation image or OpenSense, whatever BSD you want to use. And he uses the memstick image since he's going to boot off a USB thumb drive. And here's the instructions how to burn that to the USB stick, in case you don't know how to do that. And next up is you plug in the MEMU stick into your APU, attach your serial cable to your system, and then connect to it using the famous CU utility. And next up, you set
basically just a serial client.
Yeah. And then you set your COM console speed in the serial console access and COM console, of course. And then you hit boot. And once this system is coming up, you'll be prompted with a terminal type selection. In this case, he entered Xterm. But I guess the other ones are just fine. It's just personal preference. And first, you're going to set up swap and then do the rest of the partitions. So these are a couple of gpart and swap on commands, or just one swap on command. And of course, activate your network interface. This is IGB 0 in this regard. And next, you would do the HardenedBSD update to get the latest and greatest updates from HardenedBSD. And then copy your resolve conf to mount root/etc to get that the DNS works in the change root, because you're in a very constrained environment there. And finally, you mount a defFS file system because that's also needed. And now we're actually ready to dive into the change rooted environment. So you do change root/mount/root. And he added a very special extra crucial note. Make sure that you're downloading the right BIOS for your system. Do not blame him if you simply copy the next 3 commands verbatim without first ensuring they apply to your system. So you could basically just brick your system by using the wrong BIOS version. But if you pick the right one, then you do package install the FlashROM software and ch_root_nhs to get the latest certificates. And then you can use fetch, and then you basically extract that archive you downloaded from their website, and then use FlashROM-P internal board mismatch equals force, and then the name of your ROM.
Yeah,
and that should be it.
The board mismatch thing is the one you have to be especially careful with. And basically, normally the tool will not write the BIOS to it if it doesn't claim to be for the same type of board. But if you know what you're doing, just make sure you definitely have the right image.
Yeah, otherwise you just have a very expensive doorstop.
Mm-hmm. And I don't know if the APU is actually heavy enough to be a useful doorstop.
Yeah, so less use than even being that. Okay, so yeah, make sure that you don't mess this up, but afterwards you can enjoy the newer version and without any hassles that they had before. Now it's time for the news roundup this week. First, we revive a Cisco IDS into a capable OpenBSD computer.
In which they appear to have turned Puffy into a submarine and have some bombs attached to the side of it. It's a little weird.
Oh, anyway, that's cool.
I say, even though Cisco equipment is very capable, it tends to become end of life before you can say planned obsolescence. Websites become bigger, bandwidths increase, and as side effects of these improvements, routers, firewalls, and in this case, intrusion prevention systems get old quicker and quicker. Apparently, this was also the case with the Cisco IDS 4215 intrusion detection sensor that I was given a few months ago. I'm not too proud to admit that at first I didn't care about the machine itself, but rather about the add-on PCI network card with 4 fast Ethernet interfaces. The sensor was had obviously seen better days, as it had a broken front panel and needed some cleaning. But upon a closer inspection under the hood, which was held on with 4 screws, the IDS consisted of an embedded Celeron PC with 2 onboard Ethernet cards, a 2.5-inch laptop hard drive, a compact flash card, and 2 PCI expansion slots. Oh, and a nasty server-grade fan that pushed very little air but made a lot of noise. Mm-hmm. So first they replaced the fan with a sleeve-bearing 80mm Cooler Master, so it'd be much quieter. And they talk a bit about that. Storage-wise, the IDS has a 256 megabyte compact flash card, probably has a boot drive, and a 40 gigabyte IDE hard drive for data. I replaced the hard drive with a 120 gigabyte version, and because I happen to have one on hand, but held on to the original compact flash card. But then they look at the rest of the system, which is a passively cooled Celeron PGA 370 socket, and 2 sticks of RAM, giving you 512 megabytes of RAM. And it has 2 Intel 82559 Pro 100 fast Ethernet cards connected via PCI, and a USB 1.1 port, and a standard Cisco RS-232 console connector, but no onboard video or audio, making it a perfect embedded network appliance. And they have some pictures here if you want to see what it looks like. But they go about installing OpenBSD on it, especially since, with no video output or console redirection, you need to be able to do all this kind of headless. So they grabbed the latest OpenBSD from one of the mirrors, and then they slapped the i386 image down, put the Miniroot FS, put that onto the compact flash card and inserted it into the slot. Then they booted it up, plugged in the console, the Ethernet, and the power, and then connected to the serial port. And you can actually see the Cisco BIOS booting up, then starting OpenBSD. They configured the console and so on, and then it boots up.
Nice.
And then they went through the install and installed OpenBSD to the hard drive.
Not too bad.
So at that point, they killed the power, removed the compact flash card, and closed it up again, and then booted it up. And they say there's a couple of caveats. These machines have no ACPI, and as a consequence, no power management. They can't shut down from software, and they can't do wake on LAN or anything like that. A graceful shutdown is performed by halting the machine and then turning the power switch off. Also, the PCI bus has problems with interrupt allocation, making it impossible to use both of the expansion slots in their attempts, although it might be possible by making a couple changes to the BIOS or to OpenBSD. They say it's possible to upgrade the RAM, hard drive, and even the CPU. Just make sure that the power consumption stays under 50 watts, because that's all they get from the power supply. And they swapped the 4 interface 100 megabit card for a gigabit one. You can put many PCI cards inside the machine. However, only one of the slots ever seems to work at once. And if preferred, OpenBSD can be installed on a bigger compact flash card, not needing the hard drive. But that's not what they did. Yeah. Nice way to turn one of those old machines into something useful again.
Yeah, it doesn't have to go to waste. It can do its little service or whatever you purpose the machine for. Just as well. But that's not all we have about OpenBSD this week. We also have an OpenBSD desktop using Window Maker. And this is starting like the following. Since the author here of this article started using Unix, they've regularly used Window Maker. They've always liked the look and feel, the dock system and the dock apps. And it may look a bit oldish nowadays, and it's enough to try to change this. So here it is, a 2019 flavored Window Maker setup running OpenBSD 6.4 on AMD 64. First thing to do is to install the binary packages. So VM, all of those other names that could have are only required to achieve the final look. So that's easy. You do package_add on OpenBSD to get Window Maker, WMCal clock, and WMinfo, as well as WMMO. Then, as your normal user, because always don't run as root if you don't need root, run wmmaker.inst, which will install Window Maker for the current user, create a couple of directories, and copying default databases and such. And now that you have a couple of extra files like the xinitrc, xclients, or xsession scripts updated, and after that's done, the installation is finished. Next thing is to tell the XenoDM to start Window Maker when you log in. And if you use StartX rather than XenoDM or any other desktop manager or login manager, replace the .xsession by .xinitrc in the following paragraph by just removing or commenting out the user local bin wmaker line. Okay, and now you can log in and enjoy Window Maker, and there are a couple of screenshots from the desktop, how it looks like. And yeah, this gives it a bit more of a fresh look. And a couple of other color configurations are capable in, like, for example, you do the Nord color scheme change or the Apta Nocto ETA GTK theme, and or maybe the Moblin unofficial icon set. And the author also did remove the applications icon because they don't need them at the bottom of the screen as heavily, and F11 is also there to pop up the window list. To be able to do that and keep the dock apps, they tweaked the GNU-step default config files, and they provide all these files for your tweaking and customization.
Yep.
Very nice. But now we get real-time data compression.
Well, I think that's just actually the name of the blog here. But this is a post by Jan Colette, who wrote LZ4 and Z Standard, talking about opaque types and static allocations. Referring to a previous blog post, he says, "We've seen that it is possible to create opaque types. However, creation and destruction of such types must be delegated to some dedicated functions, which themselves rely on dynamic allocation mechanisms. Sometimes it can be convenient to bypass the heap and all of its malloc and free shenanigans, pushing a structure onto the stack or within thread local storage. Those are natural capabilities offered by the normal struct and can be desired at times. The previously described opaque type is so secret that it has no size, hence is not suitable for such a scenario. Fortunately, static opaque types are possible. The main idea is to create a shell type with a known size and an alignment, able to host the target private structure. For safe maintenance, the shell type and the target structure must be kept in sync by using typically a static assertion that they'll be the same size. It will ensure that the shell type is always large enough to host the target structure. This check is important to automatically detect any future evolution of the target structure. Right? If you're creating a shell type that's going to give you enough room to hold the secret type, if the secret type grows and you don't expand the shell, you're going to end up with memory corruption. And it might be hard to figure out what it was, but the static assert will make sure that it won't compile if you make that mistake.
Oh, I see. Okay.
It says, if it wasn't for the strict aliasing rule, we could have a winner. Just use the shell type as the public user-facing type, proceed with transforming it into the private type inside the unit, and it would combine properties of struct without, or while still remaining opaque. But unfortunately, the strict aliasing rule gets in the way. We can't manipulate the same memory region from two pointers of different types for the lifespan of the stored value. That's because the compiler is allowed to make assumptions about pointer value provenance for the benefit of performance. And they even have a way to visualize this issue. They have a simple example powered by Godbolt. I'm not sure what that is. Anyway, notice how the 2 + 1 get combined with a single +2, saving, or doing +1 twice is combined into doing a single +2, saving the extra save and load round trip and allowing the compiler or the computation over the variables to happen in parallel. But unfortunately, if F and I are actually the same address, then the result you would get would be wrong. And it explains why compilers do it this way.
Mm-hmm.
Interpreting differently the same memory area using different types of pointers is called type punning. It may work as long as the compiler serializes the operations as expected in the code, but there's no guarantee that that will continue to work safely in the future. A known way to break older programs employing type punning is to recompile them on a modern compiler using things like -03 or link time optimization. With enough inlining, register caching, and dead code elimination, one will start to experience strange effects which will be very hard to debug. And he has a link to where this is explained in greater detail in an excellent article by Mike Acton. For even deeper understanding of what could be happening under the hood, you can read the documentation that he provides here from Josh Simmons on how compilers work and so on. One line of defense could be disabling use of strict aliasing by the optimizer with a compiling flag like -f no strict aliasing for GCC. I wouldn't recommend it though. On top of impacting performance, it ties code correctness to a specific compiler setting, which may or may not be present in the user's project if they're embedding this compression, or if they happen to be using a different compiler. Portability is also impacted since there's no guarantee that this capability will exist in other compilers. Another line of defense consists of using the char pointer, which is the exception to this rule and can alias anything. When one memory area is passed as a character pointer, the compiler will pay attention to serialize the reads and writes properly. It works well in practice, at least in all of Jan's tests. What is worrying, though, is that in theory, the compiler is only obligated to guarantee the read is in the correct order. That it pays attention to serialize the write too seems to be just extra care the compiler is taking, which it might decide not to do someday in the future. And this is presumably done so that existing programs continue to work as intended. Not sure if it's reliable, depend on that in the long term. And so another issue is our proposed shell type is not a char table, it's a union containing a char table. That's not the same, and the exception doesn't hold true in that case. So as a consequence, the shell type might not be, or might not be confused with the target type, and the strict aliasing makes these non-interchangeable. So the trick the trick is to use a third-party initializer to convert the allocated space and return a pointer to the appropriate type. To ensure strict compliance with the C standard, it's a multi-step trick, hence a more complex setup, considering this technique as advanced, implying limited usage scenarios. So they actually have some example code of how they do one of these.
Interesting. Yeah, looking at the code. So yeah, this reminds me of my programming lectures where they always say you can make suggestions to the compiler, but the compiler itself can decide to do it either unoptimized or in a different way, so you can only hint, but don't rely too much on how the compiler behaves, because it could do something else that you don't expect.
So it ends with, to avoid direct accesses of structured members, one can still mention it clearly in code comments and use scary member names as a deterrent. A more involved way to protect struct members is to give them scary and useless names, like don't access me 1 and don't access me 2, and renaming them with macros in the code section, which can actually interpret them. Is a bit more involving, especially if the number of member names is large, potentially leading to confusion. Also, more importantly, the compiler will no longer be able to help in cases of contract violation, and protecting the design pattern will now entirely depend on reviewers, which may be not the best way to do it. Still, it's a very reasonable choice, notably the internal types which are not exposed to the user-side API and should only be manipulated by a small number of skillful contributors subject to review process. For user-facing types, though, opacity is more valuable, and if the type size is large enough to begin with, it seems like a no-brainer. Prefer the opaque type and use and only use references. This is mostly in this case talking about, I think, the Z standard API and so on, but we've kind of learned this lesson from OpenSSL, where a lot of the internal bits used to be exposed to the users of the API, and this caused people to do a bunch of things they probably shouldn't. And then, whereas in the newer version of OpenSSL, one of the things they did in the API was start making a bunch of those opaque. So you have accessors and getters and setters and so on to access the internal bits so that you aren't just randomly poking at them. And this has caused a lot of programs need to be changed. So deciding to do it the right way in your API in the first place can make a big difference.
Mm. Oh, yeah.